voila, I have my calculator now. Okay, punch your calculator. So 4 to the power 3 times -1 divided by 3 plus 2 times 4 squared plus 3 times 4, I will have I have 22 and 2/3 square units. Okay, so over here, that means the area of this area that's underneath the curve, above the x-axis, bounded between 0 to 4 is 22 and 2/3 square units. Not difficult. This is something that we all have learned when we first learn how to apply integration, right? Okay, then how is this different from today's lesson that we're trying to learn? How is it different? Over here, you notice this area between a curve and a straight line, right? So over here, what I have is curve. I don't have a straight line yet. Okay, what if Mr. Ng now introduce one straight line to you? What if I introduce one straight line here? Directly across, let's say y equals to 3. So cuts at 3. Okay, so this curve, okay, so we have a curve and then now we have a straight line. So instead of finding the area of this entire region bounded between 0 to 4, Mr. Ng only want to find the red color region. In other words, I want to find the region that's bounded between the green color curve and the horizontal red color line y equals to 3. I don't want to find everything, no. I just want to find this region only, the red color region. How do we go about doing it? Okay, it's not difficult. If you look carefully, right, I'll just color code it over here on the right hand side of the board. So area of the red color region, okay, the red region will be equals to, Mr. Ng, must I compute everything again? Okay, watch here, there's no need to. No need to. If you look carefully, right, we have already earlier found the area of this green color portion, the green color curve underneath the graph above the x-axis bounded between 0 to 4. Our answer was 22 and 2/3. We just have to take this 22 2/3 minus area under the graph. If you look carefully, what shape is this? Gina, what shape is this? Gina, what shape is this? This is a rectangle. Rectangle. It's not drawn to scale. Don't tell me it's a square. It's a rectangle. How do you know it's a square, not a rectangle? Cosine. How do you know it's a rectangle, not a square? Look over here. This shape length is how much? 3 units. This length is how much? 4 units. Right? So we know this is a rectangle, not a square. So basically, you just take this entire region, which we have previously calculated. We just subtract area of the rectangle here. So this rectangle is what? This is 4 units. This is 3 units. Okay, just get rid of the area of the rectangle. So 3 times 4 is 12. So you subtract, answer is 10 and 2/3 square units. So the area of this red color region is simply just 10 and 2/3 square units. Is that okay? Okay, some of you will ask me, Mr. Instead of finding this way, can I do it one shot way or not? One shot. Okay? Is there another way? Answer is yes. Okay, I'm going to write the alternative solution out in green color. Please pay careful attention to what I'm doing, okay? So instead of breaking up the solution into find the area of the entire curve minus area under the graph bounded above the x-axis, bounded between 0 to 4, and then I subtract the rectangle, what I can do is I can actually do this, okay? Area, okay, of the red color region. Straight away I find area of red color region. What I do is I look at this graph. What is on top, what is below? If I look carefully at this graph, you realize this graph is on top. Right, the green color graph is on top. So over here equals to bounded between negative x squared plus 4x plus 3. Okay, so this is the graph on top. I minus the graph below. So what is the graph below? The line y equals to 3. Right, the line y equals to 3. So that is the graph below, so y equals to 3. So what I do is I take the graph on top minus the graph below. So what I have is dx. Bounded between what? What are the limits? 0 to 4. 0 to 4. If I were to integrate this accordingly, right, 0 to 4 minus x squared plus 4x, 3 minus 3 is 0, disappeared. I just integrate this, right, minus x cubed over 3 plus 2x squared. I put here 0 to 4, I tell you, if I do this, my answer will also be 10 and 2/3 square units. Okay? You don't believe me, you just punch your calculator, you get exactly the same answer. So instead of doing the blue color plus the red color region, some of you, like Kareem or Sam, you want a faster approach. Winston, can I just one shot find it? Yes, you can use the green color approach, okay? So it's not difficult. So basically what you're doing is the on top line minus the below line. So in other words, right, if I have a graph that looks like this, okay, I give you another example. Let's say I have a graph, the same graph, so green color. Okay, so this is your Y1 example. Then example, this is your red color region over here, red color region. This is Y2. So I have the graph on top. Then after the red color region. So if I'm just finding the region that's bounded between your Y1 and Y2, so the area is equals to, so you must find the limits. So in this case, your A and a B, okay, bounded between A and a B. In this case, your A is 0, right? Your A is 0. But doesn't matter, I just want you to know, bounded between A and B, then this is your Y1 minus Y2 dx. Okay, so this is your on top graph minus the graph below. Okay, then you just subtract it and then simplify it, integrate, you'll find the area of the between the curve and the straight line. Okay, I'll give you another example now.